In this video, I'm going to look at arithmetic progressions, which are sequences that have a very simple growth rate. An arithmetic progression can be described recursively in a very simple way. Each term is just a constant d added on to the previous term. And that constant could be a fraction or positive or negative, but we think of the only pieces of information we need to be given are where does the sequence start? We call that value a, and then how much do I need to add on each term to get to the next term, and we'll call that number d. When you have a sequence like that, you can think generically about how the sequence grows. If the first term is a, then the second term is a plus d, and if you add d to that, you'll get a plus 2d, and if you add d to that, you'll get a plus 3d. So if you think about it in this sort of general terms, you can see that every term in an arithmetic progression is just a plus some multiple of d. The actual multiple of d depends on which one you're on, and the correspondence is pretty clear just from looking at it. If you want the nth term in this, then you need to be adding on n minus 1 multiples of d. The first term here is a plus no d's. The second term is a plus 1d. The third term is a plus 2d, and so on. So if I know I want the fourth term, I know I need to be adding on 3 multiples of d to a. So for example, with concrete numbers, in the progression 2, 5, 8, and so on, the d here is 3. You're adding 3 to go from term to term. Your first term a is 2. And so the formula for the terms in this expression are going to be 2 plus a multiple of 3. And so, for example, if you wanted the seventh term, you're going to have 2 plus 6 multiples of 3. So 2 plus 6 times 3 is 20. And if you were to write out the next 4 terms of this, you'll see that the seventh term is indeed 20. So it's fairly easy to work with. This is an important formula. It's sort of senseless to recreate this every time. This comes up a lot. Now what we're really going to talk about here is how do we sum the numbers in an arithmetic progression. So the example that I just gave, 2, 5, 8, and so on up to 20, what we really want to know is what happens if I add those numbers together, 2 plus 5 plus 8, all the way up to 20. So I'm adding the terms in an arithmetic progression. So let's think visually about what this sum would look like. If I form this sort of triangular looking array of little squares so that the number of squares on each row corresponds to each of these terms, I'll have 2 little squares up here, and then 5 little squares here, 8 little squares here, and so on. And then down here I have 20 little squares. So the answer to this sum, the value of this sum, is really just the number of little squares in this triangle. Now the visual reasoning that I'm talking about here comes from taking this picture. The number of little squares represents the answer to the question we're trying to answer, and then duplicate it. This is the same picture. I've used a slightly different shade so we can tell them apart, because what I want to do is I want to combine these two pictures. And when I say combine them, I mean take this picture, rotate it 180 degrees, and stick it right on top of this one. So I'm taking this guy, rotating 180 degrees, and putting it right here. And when I do that, I get this rectangular picture. So the only question is, what are the dimensions of this rectangle? Well, the number of rows that we have corresponds to exactly the number of terms that we're adding together. And we saw on the previous slide that there were 7 terms in this sequence, or we said that 20 was the 7th term in this arithmetic progression. So there are 7 rows because there are 7 terms that are being added together. The number of columns in this array, well, we can see on the bottom, for example, that we have the longest row of the first triangle, and we know that that has 20 little squares, and we have the shortest row of the other triangle, and we know that has 2 squares. So the total distance across here, the total number of columns that I have in this rectangle, is 20 plus 2. Well, that's not what I meant to write, but 20 plus 2. There are 22 columns in this picture because I have, and so that really is the first term of the sequence and the last term of the sequence. So the values from the original sum that I need in order to figure out the dimensions of this rectangle, I need to know the first and last term of the sum being added. I need to know how many terms I'm adding. If I know those two things, then I can build this rectangle. Now, since this rectangle is made up of the answer to the original problem twice, then I know that the answer to the original question is just half of whatever the area of this rectangle is. So I'll write that down up here. The area of this guy is 1/2 times the area of my rectangle, and my area of my rectangle is 7 by 22. So each of these two pictures have area, and by area I mean the number of little squares, 1/2 7 times 22. So when they put them together, I get this 7 by 22 rectangle. So now we're ready to state this as a theorem. In the form that we derive this, we could write down that when we add up an arithmetic progression, add up the terms of an arithmetic progression, then the sum is 1/2 n, n's the number of terms, times the first plus the last term. Now, on the first slide, we had already shown that the last term would have this form. It's a plus a multiple of d, where the multiple of d that we're using is 1 less than the number of terms. So we can simplify this expression all the way to this point, but you can see how it gets kind of complicated. So knowing all of these different forms has some value in the exercises that we'll do. So here are two problems that are very similar to the quiz problems that you'll have on this unit. First of all, we have an arithmetic progression, 1, 5, 9, 13, and so on. So we recognize immediately that the first term is 1, and the common difference is 4. And the question is just find the 20th term. Well, that's an easy question because we derived a formula that says all the terms are a plus a multiple of d, and the multiple that I need is 1 less than the term number. So 1 plus 19 times 4 is 77. The second part says find the sum of the first 20 terms. So let me just write down what I'm summing. I'll have 1 plus 5 plus 9 and so on up to the 20th term, which I've just determined to be 77. So this is adding together 20 terms. The visual explanation we just gave for how to do this gives us our answer immediately here. We don't have to do any kind of fancy plugging into formulas. We know that it's 1/2 of the number of terms and then the first plus the last term. So this is exactly the formula as we derived it with the triangle. Sum of the first and last term times the number of terms times 1/2. So in this case, that's 780. Now the second kind of problem that we could have would look like this. Find the sum of an arithmetic progression where we're told the terms, but the piece of information that's missing is how many terms there are. So in the formula, we wrote n for the number of terms, and we're not given that information here. So we need to apply a problem-solving strategy which is that we know we need a piece of information, and so before we answer the question, we should go find that piece of information. So we'll break the problem into two parts. The first part is figure out what n is, and the second part will be answering the question once we have that value of n. From the first thing that we talked about, we know that all of the terms of this sequence should look like the first term plus a multiple of d, and in this case d is 3. So we know that the nth term looks like that. In the problem, we can see that the last term that we're trying to add up is going to be 69. So we know the 69 should be our nth term, but we don't know what n is. But now we have an equation where the only unknown is the n. So we can solve this equation for n just by doing normal algebra, and we'll get n equals 22. So this guy is the 22nd term of that arithmetic progression. And now the sum, using the formula we just talked about, the sum is 1/2 times the number of terms times the sum of the first term and the last term, whatever that turns out to be.